ሰላም ለእናንተ ይሁን። ዛሬ ለዚህ ዓመትም ሆነ ለሴሚስተሩ የመጨረሻ በሆነ ቪዲዮ ነው የመጣሁት። ዛሬ በዚህ ቪዲዮ ላሳያችሁ የፈለግኩት ወይም ደግሞ ያሰብኩት ምንድን ነው ለቤዚክ ማትማቲክስ ፎር ሶሻል ሳይንስ ፋይናል ኤግዛም ዲቴል ሶሉሽን ይሆናል ማለት ነው። ስለዚህ ይሄ ፈተና እነዚህ 4 አይተሞች አሉት። ትሩ ፎልስ አለው፣ 10 ጥያቄዎች አሉ፣ ብላንክ ስፔስ አለው፣ 6 ጥያቄዎች አሉት፣ መልቲፕል ቾይስ አለው፣ 10 ጥያቄዎች እና 2 ወርክአውት ጥያቄዎቹን የያዘ ነው ማለት ነው። ስለዚህ በቀጥታ ወደ ጥያቄዎቹ ከመሄዳችን በፊት እንደተለመደው ምናልባት ለዚህ ቻናል አዲስ የሆናችሁ ሰዎች ካላችሁ ቻናሉን ሰብስክራይብ በማድረግ እንድትጀምሩ አበረታታለሁ። ይሄን ካልኩ በኋላ ቀጥታ ወደ ጥያቄዎቹ በምንሄድበት ጊዜ የመጀመሪያው ፓርት ወይም ደግሞ የመጀመሪያው አይተም ትሩ ፎልስ ማለት ነው። The first question is this one. It says the sum of two irrational numbers is irrational. The sum of two irrational numbers is irrational. So an example, just to falsify this one by considering or simply by using that counter example. Let us this one, the simple radical 2 is an irrational number. It is opposite, which is negative radical 2 is also irrational, but the sum of these two opposite irrational numbers is 0, but 0 is not irrational, it is a rational number, so that this statement is false because there are irrational numbers whose sum is not irrational or simply which is rational. ስለዚህ ይህ ጥያቄ ፎልስ ነው ማለት ነው። But that is the sum is 0 and 0 is rational, so the sum of two irrational numbers need not be irrational, so the answer is false. Question number 2. If R is a universal relation on set A, then its domain and range are equal sets. You know that a universal relation on A is said to be, it is a universal relation if it is identical with the cross product of the given set with itself. So if the relation is A cross A, then that type of relation is said to be universal relation. Therefore, when the given relation is A cross A, every element of A appears at the first coordinate for the cross product or simply within the relation, and also as a second coordinate. So that both the first and second coordinates of the relation are the same. So that in this case, the domain of the given relation is the set itself, that is A, and the range must also be the set itself, that is A, so that they become identical or simply the same. So the domain and range are equal. Hence, the answer for this question is said to be true. Question number 3. If a rational function f of x is equal to n of x over d of x has a horizontal asymptote at y is equal to 0, then its graph might cross or intersect the line y is equal to 0. You know that for such rational function, the line y is equal to 0 or the x-axis of the Cartesian coordinate system will be considered as the horizontal asymptote for the graph of the given rational function whenever the denominator of n of x is strictly less than that of the degree of the denominator, which is d of x. Therefore, a horizontal asymptote, and this horizontal asymptote describes the end behavior of the given graph, so that in this case, the graph still crosses or simply it may crosses the horizontal asymptote, that is y is equal to 0. If you consider as an example for this one, we can consider this function, this rational function, f of x equal to x over x squared plus 1. We know that from the property of the graph of a given the rational function, this rational function will have, or simply it has a horizontal asymptote because the degree of the denominator, that is simply x here, is 1, and its denominator is 2, so that the degree of the denominator is greater than that of the degree of the denominator, so that in this case, this graph or simple rational function will have a horizontal asymptote, which is y is equal to 0. But if we consider the x-intercept and the y-intercept of the given rational function, both the x-intercept could be, that is whenever x equal to 0, when that means x equal to 0, that's simply 0, 0 is the x-intercept, and even the y-intercept when x is equal to 0, x 0 በሚሆንበት ጊዜም ይሄም 0 ነው የሚሆነው። ስለዚህ the graph of the given function is crossing or simply passing through the origin. That means the graph of this rational function may intersect or simply cross the horizontal asymptote that is y is equal to 0. Therefore, the answer for this question will be true. So that means the graph of some rational function may intersect or simply cross the horizontal asymptote of the graph. Question number 4. Every polynomial function of degree n has exactly n roots. Here, the word that is exactly is very important. That means it says if every polynomial function of degree n has exactly n number of roots or simply n roots. We know that a polynomial of degree n has exactly n roots only when counted with multiplicity over the complex numbers. That means if the solution of the given polynomial function over the set of complex numbers, and if we have complex or simply roots with complexities. Question number 8. Let f be a polynomial function of degree n greater than or equal to 1. If f of a greater than 0 and f of b less than 0, then f must have exactly one real root inside a and b. Okay, this is what the location theorem says. By intermediate value theorem or by using that of location theorem, f has at least one real root in between a and b if f of a times f of b is negative, or simply f of a and f of b are opposite in sign. ልክ እዚህ ጋር እንደሰጠው ይሄኛው ፖዚቲቭ ይሄ ኔጌቲቭ ከሆነ ስለዚህ ይሄ ፋንክሽን በኤ እና በቢ መካከል ቢያንስ አንድ አለው ነው እንጂ ኤግዛክትሊ አንድ አለው አይደለም። ስለዚህ it may have more than one real root, but it may have more than one real root in the interval or simply ab. So exactly one is not guaranteed, or it is not a must. Therefore, the answer for this question would be false. Question number 9. Given two non-empty sets A and B, A cross B is equal to B cross A if and only if A is equal to B. Okay. So in this case, equality of Cartesian product always force A is equal to B. If the Cartesian product of two sets is identical, generally this could be that is A cross B is equal to B cross A. Either A and B are equal sets, or A and B are empty sets, or at least one of the two is empty. Therefore, the given sets A and B are non-empty here, so that for A cross B to be identical with B cross A, the only possibility that must be satisfied here will be A and B needs to be equal sets. እኩል ነው መሆን ያለባቸው ማለት። ስለዚህ ለምሳሌ እዚህ ጋር A እና B እነዚህ they are equal sets, then their cross product will be A cross B and B cross A are the same, therefore which are equal, therefore the converse is also true. That means if A cross B and B cross A are the same, so that this could be, from this we can imply that the individual sets A and B to be that of equal. Therefore, the answer for this statement or simple question will be true. Okay, question number 10 and the last question for this first part. Every rational number has a multiplicative inverse. When we are talking about the multiplicative inverse, we are talking, or simply we must know about the existence of multiplicative identity. We know that in the set of real number, one is the multiplicative identity, so that the rational number 0 has no multiplicative inverse because there is no such number x like that, 0 times x equal to 1. 1 is a multiplicative identity. And if 0 is given, if x is the expected multiplicative inverse of 0, their product must give us this one, but 0 times x is always 0, which is different from that of 1, so that 0 doesn't have any multiplicative inverse. ስለዚህ every rational number የሚለው because of the existence of 0 without a multiplicative inverse, this statement will becomes a false. Okay. Part 2, that is fill the blank space. Given these two functions f and g with their corresponding components, then what we are asked here is, we are asked just to calculate f over g. That is operation of functions. As function f is containing a2, b minus 1, c0, and d4, and g a12, b0, c minus 5, and a6. Therefore, in order to solve or simply just know the components or the elements of f over g depending on these two functions f and g or simple relation, then always what we know here is that the quotient f over g is said to be defined only when both are defined and g of x that the denominator is non-zero ከሆነ ብቻ ነው። ስለዚህ ካሟላ ብቻ undefined የሚሆነው። ስለዚህ ይህን ለማግኘት f over a, here we have the image of this one that simply which is equal to f of a over g of a. F of a in this case is 2, which is 2, and g of a is 12, so that 2 over 12, this is 1 over 6. Similarly, f over g of c is equal to that is c is equal to and which is f of c is 0, and the g of c is minus 5, so that 0 over negative 5, which is 0, and at g of this simply at b, g of b is equal to 0, so that f over g of b will becomes undefined. Therefore, we should exclude b from being an element of the domain of f over g. Therefore, the elements of f over g could be a with 1 over 6 and c0, so that the domain could be a and c, and the range is 1 over 6 and 0, so that they hit the answer. Question number 2, let n be to satisfy that b is a subset of a, then a minus b union b could be a blank. So in order to determine this one, since b is the subset of a, every element of a is either in b, because b is here, that is simply in b is contained in a, so that a must be either in a or in a minus b. So a minus b union b is equal to a intersection b complement, because a minus b is identical with a intersection b complement union b. Then when we use distributive property of union over intersection, we have this one, that is when we distribute b over a intersection b complement, we have a union b intersection b complement union b. But a union b could be because b the subset of a, so that it must be a, and b complement union b could be the universal set, so that we have here a union b is okay, a intersection b complement, that is a union b must be, yeah, a union b, because the largest set here is a, so that it is a, and intersection a is a itself, so that the answer could be a intersection a is equal to a, that is the answer is a, set a itself. Question number 3, let p be a polynomial function defined by p of x equal to x cubed minus 2x squared minus 5x plus 6. given that x equal to 1 is the zero of p, then the remaining zeros of p are blank. ስለዚህ ይህ ፖሊኖሚያል ፋንክሽን ተሰጠን which is cubic polynomial function። ስለዚህ including with zeros with multiplicity, this polynomial function may have 3 real roots። ስለዚህ ከነዚህ ከሶስቱ አንደኛው 0 x equal to 1 ተሰጥቶናል። ስለዚህ ቀሪዎቹን ሁለቱን ወይም ደግሞ with multiplicity ከሆነ አንደኛውን ሩት ነው የተጠየቅነው ማለት ነው። ስለዚህ ለማድረግ ምንድነው የምናደርገው? using that factor theorem, if 1 is the zero of this polynomial function, x minus 1 must be the factor of this cubic polynomial function. This is guaranteed by factor theorem. So when we divide this cubic polynomial function by x minus 1, which is the factor of this polynomial function, we have p of x, which is equal to x cubed minus 5x plus x equal to x minus 1. ያ ማለት ይሄንን በx minus 1 በምናካፍልበት ጊዜ the remainder is always 0 and the quotient will be x squared minus x minus 6. ስለዚህ የዚህ ፖሊኖሚያል ፋንክሽን ሌሎች ዜሮዎቹ የዚህ የx squared minus x minus 6 ዜሮዎች ናቸው ማለት ነው የዜሮ ካለው። ስለዚህ ይሄን ፋክተራይዝ በምናደርግበት ጊዜ ግን we have this one that is x squared minus 6 minus 6 equal to x minus 3 times x plus 2. ስለዚህ the other zeros of the given polynomial function could be the zeros of this product, that is x equal to 3 and x equal to minus 2. Therefore, the answer for this question could be that the other zeros of this cubic polynomial function other than that of 1 are x equal to 3 and x equal to minus 2. Question number 4. Let R is equal to the set containing the order pair xy such that xy is an element of R cross R such that y is equal to the square root of 1 minus x. This is a relation. Then the domain of R inverse is blank. The domain of R inverse. You know that the relationship that exists in between domain and range of R and its inverse, that is R inverse. You know that the domain of R inverse is the range of R, or the range of R inverse is the domain of R. Since y is equal to the square root of 1 minus x is given, so we must have 1 minus x must be greater than or equal to 0. That means the domain of this one could be 1 minus greater than or equal to 0 and y must be greater than or equal to 0. ስለዚህ 1 minus x greater than or equal to 0 ከሆነ y must be greater than or equal to 0, so that the range of this relation could be the set of non-negative real numbers, that is from 0 to positive infinity. ስለዚህ የr inverse domain ማለት የr range ነው። የr range-ን እዚህ አግኝተናል, so that this could be considered as the domain of the inverse of this relation, that is R inverse. Therefore, the domain of R inverse is from 0 to positive infinity, or the set of non-negative real numbers. Question number 5. The solution set of minus 3x minus 5 less than or equal to minus 2 when x is an element of z is, that is solving this linear inequality. And then when we solve the inequality, so in order to make the variable x alone here, let's add 5 to both sides of this inequality, and we have minus 3x less than or equal to 3. And when we divide both sides by minus 3, this inequality by minus 3, we have dividing by 3, reverse the sign of inequality, that is በምናባዛበትና በምናካፍልበት ጊዜ አንድ ኢኒኳሊቲ በኔጌቲቭ ነምበር ስናባዛ ወይም ደግሞ ስናካፍል ሳይን ኦፍ ኢኒኳሊቲው ሪቨርስድ ይሆናል። ያ ማለት ግሬተር ዳን የነበረው ሌስ ዳን ይሆናል፣ ወይም ሌስ ዳን የነበረው ደግሞ ግሬተር ዳን ይሆናል ማለት ነው። ስለዚህ ይሄንን በኔጌቲቭ 3 በምናካፍልበት ጊዜ we have this one, that is x greater than or equal to minus 1. ያ ማለት እዚህ ሌስ ዳን ኦር ኢኳል ቱ ነበር፣ ግሬተር ዳን ኦር ኢኳል ቱ ለምንድን ነው የሚሆነው? ምክንያቱም ይሄን ኢኒኳሊቲ ቦዝ ሳይድስ በኔጌቲቭ ቁጥር ስናካፍል ወይም ደግሞ ስናባዛ ሳይን ኦፍ ኢንኢኳሊቲ መስት ቢ ቼንጅድ ሶ ዛት ኤክስ ግሬተር ዳን ኦር ኢኳል ቱ -1 therefore ነገር ግን ይሄ ሴት ኦፍ ሪል ነምበር አይደለም ኤክስ ኢዝ አን ኤሌመንት ኦፍ ዜድ ነው ተብለናል so that the solution set could be set of integers greater than or equal to -1 or x an element of z say that x greater than or equal to -1 or in component wise we have this 1 -1 0 1 2 3 it goes on this pattern so that this could be the solution set for this linear inequality over the set of integers. Question number 6. Consider a rational function f defined by f of x equal to 2x squared minus 8 over x squared minus kx plus 4 where k is a constant real number. If the line x equal to 2 is a vertical asymptote for the graph of this rational function f, then the value of k will be blank. ስለዚህ ይህን ሶልቭ ለማድረግ ይሄ ራሽናል ፋንክሽን ተሰጥቶናል k is any constant real number x equal to የዚህ ራሽናል ፋንክሽን ቨርቲካል አሲምፕቶት ነው ከሆነ k ማን ይሆናል ነው ስለዚህ x equal to 2 የዚህ ራሽናል ፋንክሽን ቨርቲካል አሲምፕቶት ሆነ ማለት ነው አንደኛ ይሄ ሁለት ይሄን ዲኖሚኔተሩን ዜሮ ያደርገዋል but these two can never make the numerator to x squared minus 8 to be 0 ያደርገው አይችልም ቨርቲካል አሲምፕቶት ከሆነ ሁለቱንም የሚያደርግ ከሆነ ቨርቲካል አሲምፕቶት ሳይሆን ሆል ነው የሚኖረው ማለት ነው ስለዚህ ይሄን ሶልቭ በምናደርግበት ጊዜ a vertical asymptote x equal to 2 means the denominator must be 0 at x equal to 2 that means 2 square minus k2 plus 4 is equal to 2 I mean 0 then when we solve this one we have 8 minus 2k is equal to this one that is which is 0 so that the value of k here is that is 4 so that the value of k here could be 4 I mean 4 so that the equation could be 2x squared minus 8 over x squared minus 4x plus 4 okay it has something complexity but let's pass it okay the third item that is multiple choice item we have let n be any two set say that a the subset of b then which of the following is true here are the alternatives a and b n status such that a the subset of b that is every element of a is an element of b then from this alternative which one is true a minus b is a is the subset of this one that's b so that a minus b could be cannot be a it must be empty set or since a is the subset of b every element of a is in b and therefore a minus b is empty set a union b the larger set that's simply set b and the intersection of these two sets is a and the symmetric difference between these two sets that is whenever a is a subset of b could be by definition a symmetric difference of a and b is the union of a minus b and b minus a but here we have a minus b is empty set and b minus a is unknown so that it is be empty set union b minus a which is equal to b minus a therefore the true identity should be a symmetric difference b is equal to b minus e so that the true alternative for this question will be this one that's simply b so that the answer is b suppose f is a function or function from r to r satisfies f of 2x plus 1 is equal to 4x squared plus 6x plus 5 then which expression defines f of x this is just composition function opposite function ስለዚህ f of this linear that is 2x plus 1 ይህን g of x ብንለው f of g of x ማለት ነው። ስለዚህ g of x linear ነው። አውትፑቱ ኳድራቲክ በሆነ f itself must be quadratic function. The alternatives are this one. ስለዚህ ይህን ለማግኘት ወይም ደግሞ expression for f of x define ለማድረግ f of x quadratic function we know it. So let f of x is this arbitrary quadratic function whenever a is different from that of 0. Then we have 2 f of 2x plus 1 is equal to this given to be this one. ስለዚህ ይሄን 2x plus 1 እዚህ arbitrary quadratic equation ላይ በምናስገባ ጊዜ we have this one that is a into 4x square that is a times 2x plus 1 square which is 4x square plus 4x plus 1 plus b times x. X is 2x plus 1 so that we have b into 2x plus 1 plus c, we have plus c. That is identical with the given expression which is 4x square plus 6x plus 5. ስለዚህ ይሄኛውን ሶልቭ ካደረግን በኋላ we can determine the variables a, b and c. ስለዚህ a, b እና c ካገኘን exactly f of x እናገኘን ማለት ነው። ስለዚህ simplify ስናደርግ እናገኛለን we have industry ስናደርግ 4ax square plus 4a plus 2bx plus a plus b plus is equal to this one. ስለዚህ እነዚህ ኮንስታንቱ ከኮንስታንቱ ጋር የኤክስ ኮኤፊሽንት ከኤክስ ኮኤፊሽንት ጋር የኤክስ ስኩዌር ኮኤፊሽንት ከኤክስ ስኩዌር ኮኤፊሽንት ጋር እኩል መሆን አለበት። ስለዚህ taking and then equating the coefficients with the same variable and the exponents we have this one that is ለምሳሌ የኤክስ ስኩዌርን ኮኤፊሽንት በምንወስድበት ጊዜ እዚህ የኤክስ ስኩዌር ኮኤፊሽንት 4a ነው፣ እዚህ ጋር ደግሞ 4 ነው። ስለዚህ 4a must be identical with 4 ስለዚህ a ከዚህ ማን እናገኛለን ኤን a ስንት ይሆናል dividing both sides by 4 a becomes 1. Similarly taking the coefficient of x from the previous one እዚህ የኤክስ ኮኤፊሽንት 4a plus 2b ነው፣ እዚህ ደግሞ 6 ነው። ስለዚህ 4a plus b እና 6 ሁለቱ እኩል መሆን አለባቸው ማለት ነው። therefore 4a plus 2b is equal to 6 ኤን ግን እዚህ አግኝተናል a አንድ ነው። ስለዚህ 4 plus 2b is equal to 6 ይሄን ወደዚህ በምንወስድበት ጊዜ we have that is 2b is equal to 6 minus 4 that is 2 so that dividing both sides by 2 we have b is equal to 1. And lastly from the constants the constant terms of the two quadratic equation that means a plus b plus c and 5 must be equal. ስለዚህ አሁን ኤ እና ቢን እዚህ አግኝተናል። ቢ አንድ ነው ኤም አንድ ነው። ስለዚህ እዚህ ጋር ስንተካ አንድና አንድ ሁለት ይሆናል። ወደዚህ አምጥተን ከሶስቱ ላይ ስንቀንስ we have the remaining value will be 4c so that c will becomes 3. ስለዚህ the arbitrary function የፋንክሽን f of x ኮኤፊሽንቶች a b እና c እናገኘን። ስለዚህ ማን እናገኛለን f of x will be a አንድ አግኝተናል ax square b አንድ ነው it becomes 1 times x that is simply x sin እዚህ ጋር 3 አግኝተናል 3 so that the expression for the given function that is f of x will be x square plus x plus c ከዛ ይሄንን የያዘው ኦልተርኔቲቭ ደግሞ ማን ነው this alternative is this one that is a so that the answer for this question could be that is the answer is a. Question number 3. Let d be a polynomial function of degree 2 and let p be a polynomial with degree greater than 2. If p divided by d, then which polynomial could not be its remainder polynomial? Here are the alternatives. Square root of 2 times x plus 1 b is pi 0 x square plus 2. ስለዚህ ምንድነው የተሰጠን እዚህ ጋር d polynomial function of degree 2 ነው። d a polynomial function with degree 2 and pb a polynomial function of degree greater than 2. ይሄ ከሁለት ይበልጣል፣ ይሄ degree 2 ነው። ስለዚህ p በd ወይም ደግሞ እዚህ ጋር በd ወይም ደግሞ degree 2 በሆነ polynomial function ብናካፍለው the expected remainder for this polynomial function ምን ይሆናል? ስለዚህ ያካፋዩ ዲግሪ የዲ ዲግሪ ምንድነው? 2 ነው። ስለዚህ የፖሊኖሚያል ፋንክሽን ዲግሪ 2 በሆነ ፖሊኖሚያል ፋንክሽን ወይም ደግሞ ዲግሪው ከ2 በላይ የሆነ ፒ በዲግሪው 2 በሆነ ፖሊኖሚያል ፋንክሽን ዲ በሚካፈልበት ጊዜ ሪሜንደሩ ከዚህ ከዲቫይደር ዲ ዲግሪ ማነስ ስላለበት so that the expected remainder for this remainder could be either linear polynomial function with degree 1 or it could be with degree 0 that's simply constant. ስለዚህ when a polynomial is divided by degree to polynomial the remainder must have degree less than 2. ስለዚህ less than 2 ከሆነ ሪሜንደሩ ምንድነው የሚሆነው ማለት ነው? The remainder can be either constant that's with degree 0 or linear which is degree 1 but not quadratic ሊሆን ግን አይችልም። ኳድራቲክ ከሆነ ዲግሪ 2 ከሁለት በላይ ነው። ስለዚህ ማካፈል ስለሚቻል degree 2 cannot be considered as the remainder. Therefore, the answer for this one could be that is D. እነዚህኞቹ ግን እነዚህ ሊኒየሩ እና ይሄ ኮንስታንቱ ሊሆን ይችላል depending on the type of polynomial function P and D. So the correct answer here is D. Okay, question number 4. Consider the rational function g of x equal to 2x cubed minus 5x squared plus 3x plus 7 over x squared minus 3x plus 2. Which of the following lines is the asymptote for the graph of g? Y is equal to 2x minus 5, 2x minus 1, 2x plus 3, 2x plus 1. ስለዚህ እዚህ ጋር ጥያቄው የተሰጠንን በምንመለከትበት ጊዜ y is equal to x minus 5 ስለዚህ እነዚህ ሊኒየር ፖሊኖሚያል ፋንክሽኖች ወይም ደግሞ ሊኒየር ላይኖች ስትሬት ላይን ናቸው which are neither vertical nor horizontal ስለዚህ የዚህ ሆሪዞንታል አሚን ኦብሊክ አሲምፕቶት ነው ማለት ነው ምክንያቱም ይሄ ፋንክሽኑ የላይኛው ዲግሪ የታችኛውን ባንድ ስለሚበልጠው ማቴማቲካሊ ይሄ ራሽናል ፋንክሽን ኦብሊክ አሲምፕቶት ይኖረዋል ይሄ ኦብሊክ አሲምፕቶት ደግሞ የሚገኘው እንዴት ነው ከተባለ ይሄንን ላይኛውን ዲኖሚኔተሩን ለታችኛው በሎንግ ዲቪዥን በምናካፍልበት ጊዜ ኮሸንት ፖሊኖሚያል ፋንክሽኑ ማለት ነው ኦብሊክ አሲምፕቶት የሚሆነው ስለዚህ since the degree of the numerator g of x greater than the degree of degree and its denominator by 1 it will have an oblique asymptote and this asymptote is the quotient linear polynomial function which is obtained by dividing the numerator of g of x by its denominator. So when we divide 2x cubed minus 5x squared plus 3x plus 7 by x squared minus 3x plus 2, we have the quotient is 2x plus 1 and the remainder is 2. You can check it. Long division method ተጠቅመን ይህን ላይኛውን ለታችን በምናካፍልበት ጊዜ 2x plus 1 quotient polynomial function ነው and the remainder is this constant that simply 2 ይሆናል ማለት ነው። ስለዚህ ይሄ ከሆነ የዚህ ራሽናል ፋንክሽን ኦብሊክ አሲምፕቶቱ ምን ይሆናል ከተባለ y is equal to 2x plus 1 ይሆናል ማለት ነው using long division method ይህን ኤክስፕረስ በምናደርግበት ጊዜ 2x plus 1 time this one plus or 2x cubed plus this one that's simply 2 2x cubed minus 5x squared plus 2 እናገኛለን ስለዚህ ይሄ ማለት the line that is the line which is y is equal to x plus 1 y is equal to x plus 1 will be the oblique asymptote for this rational function so that the answer for this function could be alternative D. Sorry, the answer for this one could be I think it must be D. Okay. Next question, question number 5. Which of the following function is a one-to-one correspondence from A 0 to 1 to B 2 to 3? The alternatives are this one. ስለዚህ one-to-one correspondence ማለት ነው ሁለቱን የሚያሟላ one to one እና on to function ከሆነ ማለት ነው sorry ስለዚህ ይሄ function if the function is defined from n to b so which of this alternative will satisfy, or simple will becomes both 1-to-1 and onto. For example, if we take the first one, that is x plus 3, f of x equal x plus 3 over this function, it is an increasing function. ይሄ ማፕ የሚያደርገው ምንድን ነው? At the smallest one, this one that simply 0 እዚህ ጋር ሰብስቲቱት ስናደርግ it becomes 0, 0 plus 3. The smallest element within the range of this function will be 3, and the maximum value could be 4. ስለዚህ ይሄ 0 1ን ወደ 3 4 ነው እንጂ to 3 ማፕ አያደርግም። Therefore f of x equal to x plus 3 cannot be a function which is defined from a to b. ይህን ቢ በምንወስድበት ጊዜ እንደገና አሁንም ኢንክሪዚንግ ነው እዚህ ላይ over 0 to 1. ስለዚህ the smallest element is 2 and the maximum element is that simply 3. Exactly it maps to 3. ይሄ ወደዚህ ማፕ ያደርጋል። ይሄኛውን f of x is equal to x minus 1 ስንወስድ 0 ላይ minus 1 ነው። from minus 1 to positive 1 ነው የሚሆነው. That is it becomes 1 whenever x is 1, so that it maps to its range that from minus 1 to 1, execute from 0 to 1. ስለዚህ ከዚህ 1 to 1 correspondence እና from a to that of b defined የሆነውም ደግሞ ዲፋይን የሚደረገው ፋንክሽን ይሄ b ይሆናል ማለት ነው። b ብቻ ነው የሚሆነው። so that the answer could be that is b. Okay, question number 6. Let p be a polynomial with the leading coefficient 15 and the constant term 6. Then which of the following is not a rational root candidate for p? አሁን እዚህ ጋር አንድ ፖሊኖሚያል ፋንክሽን p አለኝ። የዚህ ፖሊኖሚያል ፋንክሽን ኮኤፊሽንቱ ወይም ደግሞ ሊዲንግ ኮኤፊሽንቱ the coefficient of the term with the highest exponent, that means 15 ነው። ኮንስታንት ተርሙ the term without variable 6 ነው። ስለዚህ using rational root test ለዚህ ፖሊኖሚያል ፋንክሽን possibly rational root ላይሆን የሚችለው ደግሞ ሊሆን የማይችለው የትኛው ነው ነው ጥያቄው። ስለዚህ using rational function ወይም ደግሞ rational root test possibly rational roots are plus or minus p over q whenever p divides 6 or simply p is the factor of the constant term and the q is the factor of the leading coefficient. ስለዚህ ይሄ ከሆነ ወይም ደግሞ p over q ይሄ rational number plus or minus ለዚህ rational function ወይም I mean polynomial function rational root ሊሆን የሚችለው p የኮንስታንት ተርሙ ፋክተር እና q ደግሞ የሊዲንግ ኮኤፊሽንቱ ፋክተር ሲሆን so that the possibly denominators are the denominators means that simply q which is the factors of 15 are 1 3 5 and 15 and possibly the factors or simply the possible values of p possible numerators could be the factors of 6 which are 1 2 3 and 6. ስለዚህ እነዚህን ኮምቢኔሽን በምንወስድበት ጊዜ minus 2 over 5 ምክንያቱም ሁለት እዚህ 6 ፋክተር ውስጥ አለ 5 ደግሞ ሊዲንግ ኮኤፊሽንት ፋክተር ውስጥ 15 ፋክተር ውስጥ አለ። ስለዚህ ይሄ መሆን ይችላል ኔጌቲቭ 1.5 ማለት 3 over 2 ነው። 3 እዚህ ውስጥ አለ ሁለት ግን እዚህ ሊዲንግ ኮኤፊሽንት ፋክተር ውስጥ የለም። ስለዚህ ኔጌቲቭ 1 over 5 cannot be the candidate for the rational root of this polynomial function. but 2 over 3 መሆን ይችላል። ሁለት እዚህ አለ 3 እዚህ አለ። ስለዚህ የማይሆነው ይሄ b ይሆናል ማለት ነው። b ይሆናል ማለት ነው። 3 ራሱ ይሆናል ምክንያቱም 3 እዚህ አለ አንድ እዚህ አለ 3 over 1 that means so the answer could be and the correct answer is said to be b. Question number 7. Let f of x equal to 2x minus 3 and g of x equal to the square root of 4 minus x square. Then the domain of f over g is these alternatives we have. So we need g of x to be defined and non-zero. f over g ከሆነ ያ ማለት operation on functions so that this must be defined and non-zero. First 4 minus x square must be non-negative and it must be non-zero. ስለዚህ 4 minus x square greater than or equal to 0 implies minus 2 less than x less than or equal to 2. So that also because g of x is in the denominator, so that g of x needs to be 0, non-zero that means, so that we should exclude minus 2 and positive 2 from being an element of the domain of this one, that's simply g. Therefore, we have 4 minus x squared different from that of 0 when x is different from that of plus or minus 2. Hence, the domain is from minus 2 to positive 2. And therefore, it is just the alternative could be, that means the correct answer for this one could be from minus to positive, that is A. Again, sorry, that is, it is just missed. The answer is, that is, I think, A. It must be A. Okay. Next question, question number 8. The solution set of the inequality minus 3 less than 2x minus 5 less than or equal to 9 when x is an element of z is, we have this alternative. ስለዚህ ሶልቭ በምናደርግበት ጊዜ ሌትስ ሶልቭ። አሁን ምንድነው የምናደርገው? ይቺ ኤክስ ብቻዋን እዚህ መሀል ላይ እንድትቀር ለማድረግ፣ ስለዚህ ለማድረግ ማይነስ 5 ማስወገድ አለብን፣ ኮፍሸንቱን ማስወገድ አለብን። መጀመሪያ ይህን ማይነስ 5 ለማስወገድ let's add the additive inverse of minus 5 to every term, that's minus 3, 2x minus 5 and 9. And we have 2, that is minus 5, I mean 5 plus minus 3 is 2. This is 2x, and 5 plus 9 is 40. ስለዛ x ብቻውን እንዲቀርልን ነው የምንፈልገው። ስለዚህ አሁንም ሁለትን 2x እና 14 ለሁለት በምናካፍልበት ጊዜ we can have this one less than x less than or equal to 7, so that this will be the solution set for this linear inequality. ስለዚህ x ደግሞ ኢንቲጀር ነው። ስለዚህ ይህን የያዘ the set of integers in between greater than 1 and less than or equal to 7 could be, I think, A. So the answer could be this one, that is A. Question number 9. For what values or value of k does 2x squared plus kx plus 2 is equal to 0 have two distinct real solutions? ስለዚህ ኳድራት ኢኩዌሽን ነው። ስለዚህ ዲስክሪሚናንት ሪል ሩትስ እንዲኖረው ከተፈለገ የዚህ የዲስክሪሚናንቱ ሳይን ነው የሚወስነው። ዲስክሪሚናንቱ 0 ከሆነ አንድ ሪል ሩት ብቻ ይኖረዋል። ኔጌቲቭ ከሆነ ሩት የለውም። ስለዚህ ሁለት ሩት ዲስቲንክት ሩት የሚኖረው when the discriminant, that is b square minus 4ac, is greater than 0 ሲሆን ነው። ስለዚህ በምናደርግበት ጊዜ quadratic function has two distinct real solutions when its discriminant is positive. This is the definition. For the definition, that is that discriminant could be symbolized by this one, k square, that is minus b square minus 4ac. b square here, the value of b here is k. Minus 4 times a is 2, c is also, so that k square minus 16. This needs to be positive. So k square minus 16 greater than 0 implies k square greater than 16 implies the absolute value of k is greater than 4. ስለዚህ greater than 4 የሚሆነው መቼ ነው? when k is either less than 4 or greater than 4 ሲሆን ነው ማለት ነው, because it is an absolute value. Therefore, hence k must be within an element of this one from minus 4 to negative infinity union from 4 to positive infinity, or the set of real number without the set of real numbers in between minus 4 and positive 4. So the answer could be this one, that's simply C. Next question, and the last question probably for this item. We have for what values again, and values of value of k does the remainder of g of x equal to 4x cubed plus 2x squared minus 2x plus k when divided by f of x equal to 4x plus 2 equals minus 1. ስለዚህ ምን እንደተጠየቅነው እዚህ ጋር ይሄ g of x ተሰጠን with variable that simply involving k። ስለዚህ ይሄ ፖሊኖሚያል ፋንክሽን በዚህ በf of x is equal to 4x plus 2 ብናካፍለው ሪሜንደሩ minus 1 ሊሆን የሚችለው k ማን ቢሆን ነው። That means the value of k will determine whether the value the remainder when this polynomial function divided by f of x is either minus 1 or different from that of minus 1. Okay, so let's see here በምናካፍልበት ጊዜ ወይም ደግሞ in order to determine the value of k which satisfy this condition, let's apply remainder theorem. Remainder theorem ምንድን ነው የሚለው ይሄ linear polynomial function ነው and polynomial function p of x በx minus r የሚባል linear polynomial function በሚካፈልበት ጊዜ ሪሜንደሩ p of r ነው የሚላል። ስለዚህ ጋር r ማን ነው 4x plus 2 that is if we divide both sides by 4 or simply if we factor out 4 at the increment factor it becomes 4 into x plus 1 over 2 so that r could be minus 1 over 2. This is r or simply x is minus 1 over 2. ስለዚህ g of negative 1 over 2 must be identical with minus 1. ስለዚህ linear equation ነው የምናገኘው ማለት ነው። So the remainder is g of negative 1 over 2 is equal to 4 into minus 1 over 2 cubed plus 2 into negative 1 over 2 square minus 2 times this 1 plus k. ይሄ ስንት መሆን አለበት? negative 1 መሆን አለበት። ከዛ ምን እናገኛለን እዚህ ጋር ስቴፕ ባይ ስቴፕ ሶልቭ በምናደርግበት ጊዜ ይሄን እንደዚህ እናገኛለን 2 times 1 over 4 is 1 over 2 minus 2 times 1 over 2 is 2 so that g of negative 1 over 2 could be this one that is minus 1 plus which is 1 plus k. ይሄ 0 ይሆናል 1 plus k ይቀራል። ስለዚህ ይሄ 1 plus k ከማን ጋር እኩል መሆን አለበት? it must be minus 1 which is the expected or simply the remainder. Then ይህንን ለk ሶልቭ በምናደርግበት ጊዜ k must be minus 2. That means taking this one to the right side k is equal to minus 1 which is minus 2. Therefore here the answer could be alternative B. Okay, that is all about the multiple choice item, and the last item could be that is workout item. The first question is about validity of an argument. It says investigate the validity of the argument. The given argument could be if prices are high, then wages are high. Prices are high or there are price controls. Further, if there is an inflation, then there are no price controls. The price there is an inflation. Therefore, wages are high. ስለዚህ ይህን አርጊመንት ቫሊዲቲ ቼክ ለማድረግ የመጀመሪያ ስራችን መሆን ያለበት ምንድን ነው? ይህንን በስቴትመንት ፎርም የተሰጠን አርጊመንት ወደ ሲምቦሊክ ፎርም መቀየር ነው። ስለዚህ ወደ ሲምቦሊክ ፎርም ለመቀየር እዚህ ውስጥ ያሉትን ፕሪሚሶችን ወይም ደግሞ ኮምፖነንት ስቴትመንቶችን ሲምቦላይዝ ማድረግ አለብን። ለምሳሌ from the first premise if prices are high then wages are high. ይሄ አንድ ሎጂካል ኢምፕሊኬሽን ነው። ሁለት ሲምፕል ስቴትመንቶች አሉ prices are high wages are high የሚል። ስለዚህ የምን ማድረግ እንችላለን? let p represent prices are high and w stands or simply represents wages are high. ከዛ ከሁለተኛው ፕሪሚስ prices are high or there are price controls. price are high እዚህ ጋር ኦልሬዲ ሪፕሌስ አድርገናል። ስለዚህ there are price controllers. ስለዚህ let's see represent there are price controls. And the next would be there is an inflation so that it could be represented by I. And then ሌሎች ተደጋጋሚ ናቸው። ስለዚህ እነዚህ አራት ሲምፕል ስቴትመንቶች ነው ያሉን። ቶታሊ the argument will depend on these four simple statements. ስለዚህ ይሄንን ወደ ሲምቦሊክ ፎርም በምንቀይርበት ጊዜ የመጀመሪያው ለምሳሌ if prices are high then wages are high. so that the first premise, the symbolic form of the first premise of this argument could be P implies W. And the next one could be that primes are high or there are price controls. That is P or logical destruction now here, P or C, that is P or C ይሆናል። ሁለተኛው ደግሞ further if there is an inflation then there are no price controls. A logical implication ነው. There are inflation is represented by I implies there are no price controls. ይሄ ኔጌቲቭ ነው. That's the negation of C. And the next one is that is there is an inflation which is I. Therefore, the conclusion here is wages are high, that's simply W. So that the symbolic form of this argument is this one P implies W, P or C, I implies negation of C, I, therefore W. So that this argument is equivalent to that of this one, so that whenever this argument is valid, this must also be valid. If it is invalid, this is also invalid. ከዛ ፕሪሚሶቹ እነዚህ ናቸው። አንዱ ፒ ኢምፕላይስ ደብሊው ነው። ሁለተኛው ፒ ኦር ሲ፣ third one is I implies negation of C, and the last one is I, and the conclusion is W. ስለዚህ ይሄንን ፕሩፍ በምናደርግበት ጊዜ ይህን ፕሩፍ ለማድረግ using this one formal proof, that means መጀመሪያው ለምሳሌ from if we start from the simplest statement that is simply I, let's assume that I must be true since it is a premise. ይሄ ፕሪሚስ ስለሆነ I true ነው። ስለዚህ ይሄ ፕሪሚስ ነው። ሁለተኛውን I implies negation of Q ይሄ true መሆን አለበት because it is a premise again። ነገር ግን እዚህ ጋር ምን አለኝ? I true ከሆናል I true ከሆነ I implies or simply true implies negation of C true ለመሆን negation of C itself must be true. ስለዚህ ይሄ true ከሆነ C must be false. ለምንድነው false የሚሆነው? definition of logical implication and negation። ምክንያቱም ይሄ I implies negation of C true ለመሆን I true ከሆነ negation of C true መሆን አለበት። negation of C true ከሆነ C false ነው ማለት ነው። ኦኬ ስለዚህ ሌላኛውን ፒ ኦር ሲን በምንወስድበት ጊዜ ፒ ኦር ሲ ኢዝ ትሩ መሆን አለበት። አሁንም ይሄ ፕሪሚስ ነው። ነገር ግን እዚህ ጋር ሲ ምንድን ነው ብለናል? ሲ ፎልስ ነው። ስለዚህ ሲ ፎልስ ከሆነና ፒ ኦር ሲ ትሩ መሆን ካለበት ፒ መስት ቢ ትሩ አት ሴም ታይም። ፒ ትሩ መሆን አለበት። ዴፊኒሽን ኦፍ ዲስትራክሽን ነው ይሄ። ምክንያቱም ሎጂካል ዲስትራክሽን ትሩ ለመሆን ከሁለት ኮምፖነንቶች ቢያንስ አንዱ ትሩ መሆን አለበት። ይሄኛው ግን ፎልስ ነው፣ ሲ ፎልስ ሆነ። ስለዚህ ፒ ኦር ሲ ትሩ ለመሆን የግድ ፒ ትሩ መሆን አለበት ማለት ነው። ከዛ እዚህኛው ለመጀመሪያ ፕሪሚስ ፒ ኢምፕላይስ ደብሊው በምንመጣበት ጊዜ ፒ ኢምፕላይስ ደብሊው መስት ቢ ትሩ። ሶሪ እዚህ ጋር ሲ የለም፣ ሲ ሊኖር አይችልም። that means this C must be raised. That means this one that simply P implies W must be true. premise ስለሆነ ትሩ መሆን አለበት። ነገር ግን እዚህ ጋር ስለ P ምን ብለናል? P is true። ስለዚህ ይሄ P ትሩ ከሆነ W ምን መሆን አለበት ብለን ስናስብ ልክ እዚህ ጋር መጀመሪያው ላይ ሁለተኛው ላይ እንዳየ ነው። ይሄ true implies W ትሩ ለመሆን W itself needs to be true። ይሄ ትሩ መሆን አለበት። this is the definition of implication. But what is W? W is the conclusion of this argument. ስለዚህ ምን ማለት እንችላለን? ይህ አርጊመንት ሁሉም ፕሪሚሶቹ ትሩ በሚሆኑበት ጊዜ ኮንክሉዥኑ ምን ሆነ? ትሩ ሆነ። so that this would be an indication for the validity of this argument, that is the argument is valid. Therefore the argument is valid. Okay, the last question. The last question is about graph of rational function. Consider the rational function f of x equal to 2x squared minus x minus 1 over x squared minus 1. Then, okay, I think something is missed here. ስለዚህ ባጭሩ የዚህ ፋንክሽን ግራፍ ነው የተጠየቅነው። ስለዚህ ግራፍን ለማግኘት ወይም ደግሞ ስኬች ለማድረግ ስቴፖች አሉኝ። እነዚህ ስቴፖች ምንድነው? የመጀመሪያው ስቴፕ ምንድነው? ሌትስ ፋክተራይዝ the numerator and denominator of this rational function. Factors of the numerator are 2x squared minus x minus 1 is equal to 2x plus 1 times x minus 1, and the denominator could be x squared x minus 1 times x plus 1. ስለዚህ simplify በምናደርግበት ጊዜ x minus 1 can be cancelled by this one end. They have equivalent ways. I think 2x plus 1 over x plus 1 ይሆናል። So that the denominator is 0 at x equal to plus or minus 1. So okay, step 2, the domain set of real number without plus or minus 1. Third step, let us calculate the intercepts. First, the x-intercepts could be, let us say the numerator to be equal after simplification. After simplification, that is just factorization, 2x plus 1 is equal to 0 whenever either x equal to negative 1 over 2 or x equal to 1. ሲሆን ነው የዜሮ የሚሆነው። ነገር ግን x is equal to 1 is excluded from being an element of the domain of the given rational function. ስለዚህ የዚህ x ኢንተርሰፕቱ minus 1 over 2 0 ብቻ ነው ማለት ነው። 1 0 x ኢንተርሰፕት ሊሆን አይችልም because አንድ ዶሜን ውስጥ የለም። ስለዚህ y ኢንተርሰፕቱን ለማግኘት ደግሞ ምንድነው የምናደርገው? ሲምፕሊ x 0 ማድረግ ነው። ስለዚህ x 0 ሲሆን በምናገኛለን ኦሪጂናል ፋንክሽኑ ላይ minus 1 over minus 1 which is 1, so that 0 1 could be the y-intercept of the rational function. እዚህ ጋር ራሱን ፋንክሽን በምንጠቀምበት ጊዜ ፋንክሽኑ ይሄ ነው። ስለዚህ እዚህ ጋር x 0 በሚሆንበት ጊዜ እዚህ ጋር 0 plus 1 is 1, 0 minus 1 is minus 1, 0 minus 1, 1 times minus 1 is minus 1, minus 1 times 1 is minus 1, so that it becomes minus 1 over minus 1 which is positive 1. ስለዚህ 0 1 y ኢንተርሰፕቱ ነው ማለት ነው። ከዛ በኋላ ዶሜን ካገኘን ኤክስ ኢንተርሰፕት ወይም ደግሞ ዋይ ኢንተርሰፕቶችን ቶታሊ ካገኘን የሚቀጥለው ስቴፕ ደግሞ ምንድነው? አሲምፕቶቱን ማግኘት አለብን። አሲምፕቶት ማለት ኤክስ ቨርቲካል አሲምፕቶት አለ፣ ሆሪዞንታል አሲምፕቶት አለ፣ ኦብሊክ አሲምፕቶት አለ። ስለዚህ ራሽናል ፋንክሽኑ ከነዚህ የትኞቹ ነው ያሉት የሚለውን ማወቅና እነሱንም ዲተርም ማድረግ ያስፈልጋል ማለት ነው። since x minus 1 cancels x equal to 1 is cancels ሲምፕሊፋይ በምናደርግበት ጊዜ ምክንያቱም የላይኛው የዲኖሚኔተሩም የዲኖሚኔተሩም ፋክተር ስለሆነ x minus 1 x equal to 1 ቨርቲካል አሲምፕቶት ሊሆን አይችልም። ስለዚህ ሊሆን የሚችለው ምንድነው? ሪሙቬብል ስለሆነ at x equal to 1 ራሽናል ፋንክሽኑ ቨርቲካል አሲምፕቶት ሳይሆን ሆል ነው የሚኖረው ማለት ነው። ሆሉን ቆይተን እናያለን። and the remaining denominator could be x plus 1, so the vertical asymptote ነው የሚኖረው ምክንያቱም x plus 1 ላይኛው ላይ ፋክተር አይደለም፣ አይጠፋም፣ ሪሙቬብል አይደለም። ስለዚህ x is equal to minus 1 could be a vertical asymptote for the given rational function. ስለዚህ አንድ ራሽናል ፋንክሽን ይሄ ራሽናል ፋንክሽን x equal to minus 1 የሚባል vertical asymptote አለው ማለት ነው። ሌላው since the degree of the numerator of the degree are equal or from the simplified form simplify ስናደርጋቸው ፋክተሮች ሲጠፉ ማለት ነው ዲግሪያቸው እኩል ስለሆነ ይሄ ሆሪዞንታል አሲምፕቶት አለው። ይሄ ሆሪዞንታል አሲምፕቶቱ ምን ይሆናል? ዲግሪያቸው እኩል በሚሆንበት ጊዜ የሊዲንግ ኮኤፊሺየንታቸው ኮሸንት ነው የሚሆነው። the leading coefficient of the denominator is 2 and the denominator is 1, so that 2 over 1 that is simply 2. That means y is equal to 2 will be the horizontal asymptote for the graph of the given rational function. Then ደምዚህ ጋር ምን ብለናል? x minus 1 removable factor ስለሆነ ያ ማለት የኑሜሬተሩም የዲኖሚኔተሩም ፋክተር ስለሆነ x equal to 1 vertical asymptote ሳይሆን x at x equal to 1 ሆል ይኖራል ብለን ነበር። ስለዚህ ይሄን ሆል እንዴት ነው የምናገኘው? እዚህ simplified form ላይ simplified form of the given rational function ይችን አንድ ሰብስቲቱት አድርገን የምናገኘው ቫልዩ ማለት ነው። ስለዚህ ምንድነው f of x equal to x plus 1 over x plus 1 when x equal to 1 1 times 2 is 1 I mean 2 plus 1 is 3 this is 1 plus 1 so that's 3 over 2 so that the whole would be 1 3 over 2 1 3 over 2 የሚባል ሆል ይኖረናል ማለት ስለዚህ ይህንን ፋንክሽን ግራፍ ስኬች ለማድረግ የሚያስፈልጉንን ዋና ዋና ነገሮችን ዶሜኑን አውቀናል ኢንተርሰፕቶቹን አውቀናል አሲምፕቶቶቹን አውቀናል ስለዚህ ያ ማለት ቨርቲካል አሲምፕቶት አንድ ቨርቲካል አሲምፕቶት አለው x equal to 1 ሆሪዞንታል አሲምፕቶት y is equal to 2 አለው x ኢንተርሰፕት አለው that is minus 1 over 2 0 y ኢንተርሰፕት አለው 0 1 and ሆል አለው 1 at 1 3 over 2 ላይ ሆል አለው ስለዚህ ኢንፎርሜሽን ካርቴዥያን ኮኦርዲኔት ሲስተም ላይ ካስቀመጥን በኋላ ፕሮፐርቲዎቹን ኒርደ አሲምፕቶትስ የግራፉን ባህሪ በምንመለከትበት ጊዜ roughly the graph the given rational function will looks like this one ስለዚህ ይሄ vertical asymptote ነው x equal to minus 1 this is the x intercept this one is the y intercept and this one is the whole which is 1 3 over 2 this is minus 1 over 2 0 this is 0 1 ስለዚህ በዚህ መልኩል x ወይም ደግሞ የፋንክሽኑ ግራፍ ይህ ሆሪዞንታል አሲምፕቶት y is equal to 2 ነው የዚህ ሆሪዞንታል አሲምፕቶት when the x is approaching to that vertical I mean the positive infinity the graph will approach the horizontal asymptote from below and when x approaches the vertical asymptote from the right side the functional value will goes to in the negative direction that is simply negative infinity so that the graph will looks like this from the right side of the vertical asymptote and from below the horizontal asymptote በዚህ በኩል በቀኝ በኩል በግራ በኩል በvertical asymptote በግራ በምንሄድበት ጊዜ when x approaches the vertical asymptote from the left side the functional value of the given function or simply the rational function will tend to that of positive infinity and when it is negative infinity when x tends to negative infinity the graph will tend to negative infinity from above the horizontal asymptote so that totally the graph of the given this rational function will looks like this okay thanks for watching